So here we want to find the integration of x on square root 1 minus x, and it's using u equals to 1 minus x. So as previously, what we do is we differentiate this, yeah, because we need to somehow change dx to du. The 1 just disappears, the negative x, that becomes negative 1. Now, when I multiply that over, that's going to be dx equals to negative du. You can see there's no x there. And what that means is when I substitute it in, it's not going to cancel, okay? So I need another way to get rid of that x. And what I can do is rearrange this equation here. So from here, I can move the x over here and the u over there and get that x equals to 1 minus u, yeah? So I'll show you how that works. So here, I want to integrate x on that. And if I did it like in the previous questions, that would leave me with x on. So that becomes u, so square root u. And dx in this case is just negative du. So can you see here, there's no x's to cancel that out. We're left with this x and we can't do anything because differentiating in terms of u, that x is still going to be there, and that's a really big problem. So what we need to use is essentially the rearrangement of this equation, okay? So because I worked out that x equals to 1 minus u, I'm going to change this x here to the 1 minus u there. Can you see that? How I've changed that to that using that? Great, so now I've done this, you can just work that out. So the negative here, I'm just going to multiply everything here by negative. It's just, you need to make this just du by itself. So that becomes u minus 1. And now it's just a matter of integrating that. And the best way of doing this is just to split the fraction. So you have u on square root u and then minus integration of 1 on square root u. And this here, because u on square root u, that is essentially the same as square root u times square root u on that. Do you know what I mean? So that's just 2 square root u. So that's why I can cancel that and make that just square root u, which is why this is just u to the power of half, yeah? And that's going to be u to the power of negative half there. All right, so let's integrate. So from here, it's pretty basic. So plus 1 and 1 on half plus 1, negative half plus 1 and 1 on that as well. So this becomes u to the power of 3 on 2. And this becomes 1 on 3 on 2, yeah? And that 2 goes on top, which is why it becomes 2 on 3. Whereas over here, negative half plus 1 gives you half. 1 on half, that 2 goes to the top, and that's why you get a negative 2 there. And remember your plus c, and always check, have I substituted back into the x form? No, I haven't, so let's do that. And then finally, because here it's not in the index form, but in the square root form, I have to do the same thing. So remember 3 is the index, 2 is the root, 1 is the index there, 2 is just the root. So it's just a square root there and plus c at the end, okay? So you can see what I mean by this is kind of an extension of the previous method. So everything is actually exactly the same. The only difference is when I substituted in the du for dx, I couldn't cancel that x. So I needed essentially an additional method, which is rearrangement of that equation to get rid of my x there. And so just remember, it makes a lot of sense. You just want it to all be u, yeah? You can't do anything if there's an x there. You need everything to be u, so you rearrange that so x equals to u and substitute it in. That's the basics of it all. All right, great.